Thanks for all coming today, everybody. This is going to be really exciting. I'm glad that so many people find this topic interesting. I certainly do. I've been talking about Docker now for a while, and Swarm for a little while as well. And a lot of you, who here has played with Docker before? Okay, good, because we're not going to cover very much of the basics at all. I'm going to breeze right through that, assuming everyone knows what containers are, sort of how to get them up and running, and why you'd want to be using them in the first place. This talk is really going to focus much more on the swarm mode aspects of Docker CE, why it's useful, how to use it with Asterisk, and how to use it with anything in general. Because I found that people haven't played with this as much due to the fact that it was fairly unstable for a long time. There were a lot of problems with it up until really Docker 1.13. And they switched their naming scheme to 17 point whatever, and then it got really good and really fun, and now it's super duper awesome, and I think everyone should love it. So let's move on. I'm Evan McGee, like James was saying. I was and am the CTO of Ring Plus. We are we were an MVNO for a while, and now we're sort of an MVNO technology company. And I do a lot of consulting in the space and a couple other things. I'm basically a human phone assistant, and I assist phones to be better in their technology. But we're really here to talk about Asterisk and Docker. So again, just to cover really quick, people who don't know, Docker is a framework for deploying and maintaining and creating containers. Containers, in my mind, just to keep everyone on the same task here, or in the same mindset, I really do subscribe to the idea that containers should be single processes. You shouldn't be trying to duplicate a VM inside of a container. If you're running more than one process inside of a container, there's probably a way to break that apart. And it may be more logistically complex and DevOps heavy, but you really should be trying to do that. Keep them as small and as ephemeral as possible. If you have dependencies, they should be somewhere else, like in S3. If you have assets, you should be pulling these down in and out. And that's actually going to be very important talking about Swarm, because as you'll see, things when deployed to Swarm don't necessarily have access to the same underlying file system or a number of other things. So you have to really be careful that what you're doing is replicatable across any number of instances without having any problems. Yeah, why do I love it? The higher packing density, and the fact we can run all these things in the same realm, which is kind of fun. Okay, let's move on to Docker Swarm mode. So Swarm mode, I should clarify what Swarm mode means. So the guys at Docker were not particularly good at naming things for a while, and so there was Docker, and then there was Docker Swarm, and Docker Swarm sort of didn't work, and they said it did, and it's production ready in 1.12, and they were just wrong. And then Docker Swarm mode. Swarm mode is basically Docker Swarm kit built into the Docker CE engine. See, this is already way too confusing. And then it's, of course, the way you deploy files is with compose file format, but you're not actually using Docker compose. And we'll get to that. Point is, when you Google this later, you're looking for Swarm mode. There's no hyphen in that. I don't know why I put a hyphen there. There's no hyphen in it in real life. But you're looking for Docker Swarm mode. That is the one built into the Docker CE engine and is the one we're really going to be talking about. And what does it really allow? Well, why do you want to use Swarm? Swarm allows you to do, Docker, as we all know, is a single machine container engine. Swarm mode allows you to span this over multiple machines. What it does is it gives you the ability to do a VXLAN overlay network on top of all of your CE engines so you can all communicate together, right? Basically, it makes it so you can run an entire, basically, miniature cloud of your own. Swarm also has a lot of really built-in amazing functions, things like state reconciliation, health checking, all of this built in to basically make sure your containers are up and stay up. And I think that's pretty great. A lot of these things are replacing tools you might have been using before, either cron scripts or health check scripts or a bunch of other things that we'll get to. The mesh networking is also very interesting. So this is another great aspect of it that I think is super duper cool. When you set up your Swarm, you get through that basically a super advanced IPVS level in-kernel routing mesh network. And what that means, and you'll see this in a little bit later slides, is that if I have 3 nodes, let's say one's in London, one's in San Francisco, and one's in New York, and I try to access, and I publish an Nginx service, which we'll get to, and I publish it on port 80 and the container's deployed in San Francisco. So I have one Nginx running on port 80 in San Francisco. If I hit the IP address in London, the mesh network is going to route that from London all the way to the container in San Francisco and back again transparently. So the person on the actual accessing the site has no idea where the container is running. That port is published across all the different nodes in the Swarm. You can access a container that's running anywhere from anywhere else, and it just sort of seamlessly blends together, and it doesn't hit user space as the networking goes through. And that's kind of an unbelievable thing, because if you think about it, suddenly let's say we have, the built-in resiliency there is kind of incredible. backed up with the idea that Swarm can say, make sure these containers are up or down. So if you have running like 3 Nginxes and you have 50 endpoints, suddenly anyone can get from any of those endpoints to anywhere else, and everything just kind of works magically. It's kind of an unbelievable thing. But there's some DNS-based service discovery that we'll also get to. When you're inside the mesh network, when you're inside Swarm doing stuff, and you're running, say, Nginx, and you call that service Nginx, from any container inside of the overlay network, you can say ping Nginx, and it actually hits inside a Docker internal DNS resolver that then resolves that to one of the running instances of Nginx, right? So you can say, you can access your services from other services by referring to them by name. So you can say, I want to get to, so let's say Asterisk needs to talk to, again, like a web server, you can say, or like a Rails server, right? You just call your service Rails, and Asterisk says, well, I need to get something from Rails, and it says, great, because that is a stateless transaction. It can hit any of the Rails servers that are running anywhere on the network, and it just kind of goes. Again, easy rolling updates, ease of scaling, and unfortunately, on the enterprise edition of Docker, you get a free basket of puppies, but we run the community edition, so there's no puppies for us. So let's get to deploying, right? So this is a lot of talk, and let's just actually get to actually doing this. So the first thing you want to do is spin up a few machines with your favorite OS, right? In this one, we're going to be using Debian 9. Actually, it's Debian 8 a lot still, because a lot of things haven't upgraded to stretch. But if you can choose whatever you want, it doesn't matter. It runs on CentOS, runs on all your favorite flavor, even Windows and Mac OS. So, although note that Docker on Mac OS is actually inside of and it might be on Windows. I've never actually played with it on Windows, but on Mac OS, it's inside of a virtualized, inside of a VM anyway. So certain features on a Mac don't work like they do on Linux. So if you have any ability to run this on Linux, just do it on that because it's just easier. And everything works the way you expect and the way the documentation says. As soon as you get onto a different platform, things start to get a little wonky sometimes. So just installing Docker CE, we all kind of know how to do this. So this is just here in case someone needs it. This is literally just pulled from the Docker site, right? You're just doing a bunch of apt-get updates. You're pulling down the actual repository. And then you're just installing Docker CE. This is exactly how you get Docker running. So you just need to do this on every node, right? Every node has to have this. What we do normally is deploy in DigitalOcean. We do this. We then image that into a snapshot, and we can deploy that snapshot wherever we want. So you'd have a Debian 9 with Docker 1709 on it, and you can just start deploying that, make that available in all the different regions you want, and off you go. And voila, there we are. So you have your little Docker V there, and you're running 1709. So now we get to the fun part. Let's initialize the swarm. So as a note, if you are running any firewalls or anything else, these are the ports you need to have opened up, right? There's a bunch of different communications that goes on here. The manager nodes in Swarm, there are 2 different kinds of nodes in Swarm. There's a manager node and there are worker nodes. Manager nodes are also worker nodes, so don't think you're like setting aside a VM to just do nothing. It actually just has a little bit of overhead. The manager nodes keep state on the entire Swarm. You should have as many of them as you want, at least 2, probably 3. And they use a Raft consensus algorithm, so they have to communicate amongst themselves to make sure, elect the leader, make sure they know who's in charge of the Swarm, because you don't want any kind of conflict in that. And the actual nodes themselves use the gossip protocol to kind of talk back and forth and figure out who has what. So these are the ports you have to have open, basically, to have everything communicate properly. If you don't have those open, you'll just get some weird errors and things won't talk to each other. Again, if you're doing this maybe on DigitalOcean, if you're inside the same data center, you can use private networking, so you don't have to worry about any of the firewalls. But if you have firewalls on the outside and you're using this amongst data centers, just make sure that you have this sort of stuff open. So here we go. So we're just going to init the swarm here real fast. So that's really all it is, Docker swarm init, and then you give the advertising address. That address is, in this case, the external address of a DigitalOcean VM running in San Francisco. And that's it. This is what it prints out. So here you go. That's literally all you have to do to get this swarm to get the first manager up going. So what's great about Docker is they've done a really, really nice job of making this as simple as possible and making it accessible and giving you fairly helpful notes along the way, right? This is a great output here. It tells you exactly what to run on your following nodes to join the swarm. Super nice, super helpful. You really just need to copy and paste that into the rest of the nodes to get them to join, right? So run that on each line, right? And that's all you have to do. So here, I'm actually going to, for a second, just do this. So I have these are the 3 nodes that are on there, right? So we're just going to go, let's see here, Docker swarm init advertise address. Actually, forget the address of this machine, one sec. It is the same one that's on here. So just take that over here. I can't spell advertise. See, actually, it has tab completion of everything. So I'm sorry it's a little cramped there, but kablamo, there you go, the swarm's initted. So we go over here, we just copy and paste, bam, bam, and bam. You can see this node has joined as a worker. This node has joined as a worker. So this one over here on the far right is in London. This one's in New York. This one's in San Francisco. All right, sweet. Back to fun. Oh, it resets? That's too bad. OK, so Swarm is ready. There we go. Docker node ls. You can see this is what it will print out now if I go back and do it. You're going to see SFO is the leader. You're going to see New York and London are active and available. Status is ready. Swarm is good to go. We're ready to start deploying services. In this case, we only have a single manager. And managers, like I said before, have a little bit more overhead, but feel free to use more of them. As your Swarm grows, and we're talking, if you're really deploying huge numbers of nodes here on the order of thousands, then you're going to have a lot more traffic going to the managers than not. So in that case, make sure you profile how much more CPU the Docker daemon is using on those manager nodes. But for a reasonable sized network, it's really not a big overhead. So let's move on to doing Asterisk in Docker Swarm. This is where it gets a little fun, because as we know, our domain is special. We're special people. We should all feel special. And Asterisk itself is very special. And it also has some weird considerations that things like, again, stateless web servers don't have. There's lots of state going on. So Asterisk in Swarm mode. See how I didn't get the hyphen there this time, because I was smarter as I went on? What we're going to do here is, let me make sure I want to talk about this the right way. So in order to get Asterisk up and running, as we all know, you have to have a container of it somewhere, right? Generally, there are no real generic containers for Asterisk out there that cover everyone's specific use case. They generally have like vanilla configs. There's quite a lot that goes into actually getting that set up. And I'm going to leave that as an exercise for you guys to get your Asterisk image ready to go in the way you want. Copying your config files in, figuring out how you need to do it. That's a whole other talk. We can talk about how to make that happen. For this one, we're going to be using the generic Bespoke Asterisk 14 image that's out there, because it just does pop up with the like super awesome company default configs, and it's there and it works great. And Digi made it, so I'm excited by it. In order to deploy something on Swarm, the newest way to do that is to use what's called a stack file. So what is a stack file? Well, who here has used Docker Compose? Anybody? Yeah, okay, a couple people. So Docker Compose is simply a YAML file that defines how you want your image to be built. So you have your Docker file, right? Your Docker file is actually the actual commands, like install this thing, run this thing, set these variables, change the stuff around. The Compose file says, cool, use that Docker file and build that into this image. Let's say Bespoke, Asterisk 14. Build it to that image, and then add some following constraints, and then deploy that thing. We're going to get here in a second. And then the stack file is basically a Compose file that without all the options, but in the same format. And the reason I'm trying to get this across is that, again, when you go out and look this up, it's going to be a little confusing because the documentation is somewhat fractured and a little bit fragmented in the sense that you'll look at what you want to look up when deploying swarms is how to deploy stacks on a swarm, because you're going to find a thing called services. The services are the actual like images you're deploying. So if you're having Nginx or Rails, those are your services of Nginx or Rails, or your service of Asterisk. And you're going to be deploying those onto your swarm using your stack file. So stack, deploy, off we go. So I know it's a little bit strange, but again, they're very simple YAML files. We're going to go through a couple of them right now, so you can see really how simple they are. And you can make them very complex and very sort of, very cool. But I've been mentioning Nginx a lot, and the reason why is I want to break for that for a second, because this is a much simpler version to understand before we move on to Asterisk. We have to deal with some other complexities. This is a simple stack file for deploying just like a random, like vanilla Nginx with nothing else. This is all you have to do. That's all it is. So the version up here is the laser, sweet. 3.4 is the most recent version of Compose format. They change this all the time. Docker is constantly upgrading, as I think we all know. So they're up to 3.4. It was like 3.0 maybe 3 months ago. And each time they add a dot revision, you're getting more features you can put into the Compose file to deploy onto your swarm. Things like the ability to do host-level networking, which we'll use for Asterisk later. That wasn't available until like 3 weeks ago. So this is actually changing pretty rapidly, which is great. They're adding in a lot of features that everybody needs. Something else is interesting in here. So you'll see right here, these are the services. You just define the services. There's one just called Nginx. That's just the name of the service. It has nothing to do with the image itself. The image here is Nginx. It's going to pull that from Docker Hub. If you just have a random name here, like anything else, it'll just do a random Docker pull onto whatever node you need. I'm going to expose port 80 across the entire mesh network. So this is going to say anywhere a node exists, we're going to have port 80 available, and it's going to route to this service. And here's the network it's going to run on. It's going to run on Asterisk Radical. And what is that? That's the overlay network that's going to run across the entire swarm. So right now, as you saw with like those 3 nodes that I have up, the nodes are in the swarm, but there's nothing really connecting them, right? Except for the management network. There's no actual like networking between them yet. This automatically creates the Asterisk Radical attachable network, and that then goes and creates that on each one of those nodes once an image is actually deployed there. So it knows, it's smart enough to say, hey, I'm running Nginx on the London node, and I'm also running one on San Francisco. Make sure that both of them are running the Asterisk Radical overlay network so they can talk to each other internally via the services, right? And this is kind of great because all you need to do is put this in here, and the rest of that just all happens. Right? And that's what's kind of amazing. It all just works, and it happens, and it's fantastic. And that's why I got to give credit to these guys. This is stuff that was a little bit wonky in like 1.12 and 1.13, and they finally nailed it, and it seems to work pretty gosh darn well. This attachable true down here is something, just a little bit of a tidbit. That I throw in all of mine. If you don't have that in there, then this network, Asterisk Radical, it's only available from services inside this stack file that you've deployed. If you put attachable as true, then you can arbitrarily attach any container you want to it to do things like diagnostics or ping stuff. I'm not sure why that's not a default. It seems to me like you'd always want the ability to be able to attach a container to a running overlay network, but it's not. It's not the default. You actually have to put that in there. Anyway, so here's how you do it, right? I'm talking a lot. Here's some more stuff. This is all you have to do. Docker stack deploy. You give it the name of the YAML file, which is just that stack that we looked at, and what you want to call it. And this is what it does, creating Asterisk Swarm. So this is creating the network, right? There it is right there. And this is creating the service itself, just Nginx. Sweet, and then we can check it, Docker service ls. So now we're using, we've done Docker stack deploy, Docker node ls, check on the nodes, and Docker service, we're looking at the service level. Here's the service, Asterisk Swarm, which is what we named it up here, Nginx, which is the name of the service. Replicated, we have 1 out of 1. It's running, this is the image from Docker Hub that it's running, and then here are the ports that are exposed. So, this is all pretty straightforward, but let's just do that real quick so we can actually see that it works. And I'm not just making stuff up as we go along. All right, so I actually have those files in here, and we're just going to go here, stack deploy. Need to specify the config file for Nginx, and then, let's call it Asterisk. But bam, there we go, deployed. Docker service ls, there they are. It's a little squished. Hold on, let me expand that real fast. Whoops. You get it. Come on. You get it. You can see it's there now. Sort of 1 out of 1. Nginx is there. Now, the next thing I was going to say over here is that the scaling. So, great. Now we have 1 running. Terrific. We have 1. Yay. 1. That's not why we're doing this. We're not doing this for 1. We're doing this because we want to have many of these things all operating in high availability and backing each other up. So let's just scale it up. Great, Docker service scale. I'll get to the detached thing in a second. Asterisk Swarm, you just give it the number of replicas you want. You can also specify your number of replicas in the stack file if you want to start up with like 8 or 20 or whatever you want. But yeah, that's it. And that's literally all it does, is then just scales it up and check it out. So now if we go back to this one real quick. Ba-bam. So again, these commands have to be run from the manager node. That's kind of a hint. If you try to run them from over here, like this one's not manager, let's try Docker node ls, it's just going to complain at you that this is not a swarm manager. Worker nodes don't do anything besides run images. So you'll get that error. It nicely tells you don't do that here. Let's go back over here. So let's just go Docker service scale, and we only have 1 service, so it kind of knows it. Asterisk 2. Now, if I don't hit that detach equals true, there's a new. Actually, I'm going to put detach. It's going to tell me it's deprecated. Watch. All right, so there it says deprecated. Blam, right? Detach equals false. This is kind of nice. Again, the Docker guys are telling you they're going to make detach false as a not a default. What that means is that this scales it in the background, so you can't really see what's happening. If I put detach equals true in here. Detach equals true. Let's scale it up to like 3. Why not? Ba-bam. then you'll see that deprecation goes away. If I actually specify detach equals false, and we scale it back down to 2, it tells you it's verifying the tasks are running, 1 out of 2 running, verifying that the network's actually stable and the services have converged. So if you want to actually scale things and see what it's doing, then you can actually do it with detach equals true and tells you in real time. Otherwise, it'll do it all in the background. So now, if we just clear that off and go docker service ls, we should see 2 running. Whoops. Yep, we see 2 out of 2. Let's just check the Docker on running here. Oh, look, one's running on. You don't know where they're running. The point is, like, they can run on any of them. So who knows where they're actually running? You can do like a Docker service PS, and it'll actually tell you. Whoops. There we go. And it'll tell you that one of them's running on Astricon SFO, and one of them's running on Astricon NYC, right? So over here on London, we'll go over to London and check it out. And there's nothing running in London. That's sad. All our European friends don't have anything running. If we do like a Docker network ls, you'll also notice that there is no special network here. Check it out. Like, this is the networks that are over here. It's just the Docker bridge, the host, the ingress, nothing special. But if we go to this one over here where an actual node is running, and we do a Docker network ls, you're going to see, check that out. There's our overlay network, dynamically created by the Docker engine when deploying this Nginx. So that's all kind of fun and games. So again, what happens, what's nice about this, now we have 2 replicas running, and the Docker engine will make sure that that stays in state. So if we had one running on London and London caught fire or something happened, it'll see that there's only 1 out of 2 running and move the container over to SFO, and everything will be all hunky-dory. So the more node workers you have, the more resiliency you have, and these nodes, because it will just replicate around if there is ever a problem with a node. With an actual service. And in this case, the Nginx service would actually have to die. The container itself has to exit to realize something's happened. We'll get to that with Asterisk, or maybe it's actually not processing, but the process is still running. How do you deal with that, right? How do you deal with basically something that's hung, but the container is still up? So the swarm thinks it's good to go, but your service is down. That's another big problem. Okay. So we've talked about this a little bit. Again, the overlay network is kind of fun, right? It takes these individual machines in SFO, London, whatever, links them by an internal network with its own Docker IP range, and then you can ping by service name. And again, to go back over to here real quick, is it useful for me to be doing this live for everybody to see me doing this? Okay, because I can just go through. I have it all on the slides. So you can review it later. But I thought it'd be kind of fun just to see like literally how fast this can be if you're trying to get it done. So let's go over to this guy. All right, so I'm over in SFO. I want to go. Let's check out the network real fast. There it is. Astricon is radical. I'm going to connect to that one. Let's see here. I'm just going to run like a random Debian container. I got to specify my network though. So my network is going to be Astricon is radical, terrific. Debian, let's run bash inside that, right? So there we go. So now I'm inside the container, we're just running bash and Debian, but I'm attached to the overlay network. So now I should be able just to ping Nginx, and look at that, right? So that's pinging one of the Nginx services. Now there are 2 different kinds of service discovery inside Docker Swarm. There is one that uses an internal DNS resolver, and it actually presents a virtual IP, which is what you connect to get to any one of them, and it just sort of does internal load balancing over them. You can also specify in the stack file to use DNS round robin if you don't want to use a virtualized IP. It depends on your deployment, what you're trying to do, right? So there are multiple ways to do this. This is using the virtual IP one, so I don't really know which one I'm hitting. I probably could tell from the fact that like the last one was what? I'm hitting, this one is probably routing me to the nearest one. Probably, because the ping time on that is 0.1 seconds. If I was trying to, if it was sending me over to the New York one, it'd have to go from San Francisco to New York. So that ping time would naturally be higher. I'm not sure I can drain the node here real quick. But anyway, point being that you can actually tell from these internal ping times sort of where in your network it is. Yeah, the point of that is to show you that you can access services by name. And that becomes actually a super duper fun and great when you're deploying any kind of thing where you're just like, great, just you don't have to refer to anything by IP address anymore. You just say, great, get to the service Nginx, get to the service, asset proxy, whatever you want to do. Just refer to that, and as long as it's running somewhere on the node or somewhere on the network, it's going to be accessible. So let's get back to the asterisk stack file. Now we get to some fun of just actually doing asterisk in Swarm. So the big problem here, and the big problem historically, is RTP. RTP is the big problem. Why is RTP the big problem? because RTP uses an insane number of ports. RTP, there's 4 ports. Without using RTCP MUX, there are roughly 4 ports per row call. And that's a lot. And the way Docker sets up ports is it sets up IP tables rules to route these things around. This is all done through IP tables in the background. And the issue is that Docker doesn't do ranges. It sets up individual ports. So if you expose 10,000 ports, it's going to try to set up 10,000 single IP tables rules to route those around. And it just destroys machines. It just can't be done. And this has been a discussion with them for years about, like, can't we get around this? Particularly coming from people in the real-time communications world, because this is something that we suffer from. And almost nobody else does, because no one uses such a high number of ports. There is one way around it, and the one way around it is to use what's called host mode. And what does that mean? Well, it means that the container no longer has access to the overlay networks or anything like that. You can't use any of that kind of service discovery mechanism, but it does expose the entire underlying networking subsystem, so you don't have to worry about ports at all. Basically, you're running it on like the native networking stack, and everything is exposed. The entire container is open to the world to do whatever you want. So it's basically like encapsulating your Asterisk, like you would do it on basically a bare metal or a VM, but inside of a container. And with that, it comes like, the high availability. You can actually move this around and that kind of stuff, but you lose some of the networking niceness. If you're not running that many calls for a machine, unless you're doing like a small office PBX, then yeah, you can actually run it inside the mesh network. And if you're exposing 100 ports, because you're only expecting 25 or 50 calls or whatever, then that's fine, right? That's your maximum concurrent number, and you want to just do that, and you're not, that's great. You can just run it inside. And that's the one over here, right? Just normally, no normal stack file. Fortunately, as of about 3 or 4 weeks ago, you couldn't actually do this host mode inside of Swarm. You had to set it up externally and then just reference it like we're going to in a minute. They added this about in 3.3, I think in the beginning of the month or last month. They added the ability to actually do a host mode external network that you could then deploy as. And what it means basically just goes to the node that wants to deploy Asterisk on, says run this in host mode, and then off you go. And that's great. I mean, this is the kind of things that they've been looking for. And if you go into the Docker GitHub and look at all the issues that are there, you can almost always find problems that we have somewhere in there referenced by somebody, and then just follow along the conversation or give it a little like thumbs up, like, yeah, this is an issue. They do get around to fixing these things fairly quickly. That's great. So like I said, this is a problem. Each UDP port you open, the reason why it kind of explodes is it uses about a megabyte per when it gets up high enough. And that's just, that just gets terrible, right? 10,000 ports, you can't have that. It just doesn't work. Plus it times out. You can't even start the container. The whole thing explodes. And we kind of covered this, right? So overlay mode is the one you can use if you have a small number of ports. Host mode is the one that we're going to use because we like lots of ports. Now, there is a secret trick. So the guys at Better Voice and the women and men at Better Voice, who are just tremendous engineers, and I can't give them enough credit, came up with this little trick guy right here. This is a series of IP tables commands that if you want to run an overlay network on a node, okay, you actually want to run this inside of the normal Swarm and use all the overlay stuff, don't expose your UDP range, just run this on the nodes that it's running on. So basically you want to specify a certain node that Asterisk will run on. You can use that by using node labels. You can label a certain machine, only run Asterisk on these like 3 machines. Go on there and then run these IP tables commands. And this will open up all the port ranges using the normal IP tables range commands, right? This is like the 10,000 to 65,000. And this is great, right? This is all you need. And that actually just makes it all work. Everything comes in, it goes to the correct running container. And it allows you to do everything you want. Only issue is that you can't run this command from Docker Swarm anywhere, right? There is a way, I think you might know there's a way to run a privileged container that allows you to like add your own IP tables rules. It doesn't work in Swarm yet. You can't do that. You can't have privileged containers that access underlying things. So this would have to be run externally once the container is already up and mounted. As you see, it looks up the networking IP address of the container on that node and then just jams it in here. Where is it there? And down over here. So you'd have to get the node up and running, have Asterisk running, and then run this command. Again, not a huge problem, but kind of a pain, right? We don't want that. This is the whole thing we're trying to avoid, is doing like one-off stuff like this, right? This is exactly what I hate. So hopefully they'll make this available, or they'll give us ranges at some point in the future, and all of this will go away. But Better Voice, again, they came up with this little trick right here, and it's actually from their GitHub repo of how they deploy, which is interesting. So anyway, we're going to come back here, and we're going to use the one where we deploy with host mode. So you get all the fun port ranges and everything else like that. It works much more like a traditional Asterisk installation in the sense that you have access to everything. It does still function. What's nice is that because it's still running inside Swarm, you still get all the available health checks and everything else, right? The container's still up and running and managed by the network, you just don't have access to the networking elements. All right, so some additional pieces. So if you want to keep this also available, so now you have Asterisk running. Let's say you have Asterisk up on, and let's just do that real quick. Why am I telling you? How much time we got left? All right, so we're going to go here, and we're just going to go, see, I have this stack file right here. There it is, same thing. It's actually running Nginx as well. Doesn't really matter. So I'm going to take down the previous one. This is how you destroy a network, by the way. Docker stack rm astricon. There we go, it's gone. And you can see over here, it's removed that running Nginx I had over here, and it's removed the overlay network. So we're back to just running absolutely nothing. So now if we go docker stack deploy asterisk, astricon, it's going to create the network again. It's running asterisk, it's running everything else. There we go. Docker service ls. There they are running. Terrific. So asterisk is running one of them. I'm not sure where they're running, so we have to look it up. Oh, look, asterisk is on this box. How nice is that? So there we go, right? And you can actually do like a Docker. So it's nice also that you can actually get the logs from everything. Log shipping is a big part of this as well. You can get into that. Ship your logs wherever you want to go. There's logging drivers. You can also just look at the logs from a service level. So every instance will dump its logs here. Service logs, and I'm just going to go with, what's this one called? Astricon asterisk. Boop, you know. And of course it's trying, I think somebody's already banging on it. Yeah, asterisk is ready. Somebody's actually already trying to like access it. Right? That's why you want to have things in front of this. But there, I mean, that's just the logs from that service. That service could be running anywhere. It could be running in London or wherever else, and we're good to go. So, you know, another thing, so come into play now. So here's the issue. You've lost access to the overlay network. You've lost access to the ingress mesh network. So any kind of thing that's coming in on port 5060, normally if you're running it on an overlay network, 5060 could come in London, it would route it to the asterisk in San Francisco and back again, and you'd be great. Same with the UDP, it would just flow through and go right back again. You've lost that, so now you're back to having like a static IP address or a static machine that's running asterisk, which is not great, but we know how to solve this, right? We know how to do this. It's not a big deal. If you have a number of these machines labeled, and let's say you're running this in triplicate somewhere because you have, running a real-time database in the back ends, these asterisk machines are as stateless as you can make them in terms of their actual configuration, then use something like, Route 53's GeoDNS, where you can just say anyone coming from Europe is going to get this thing. Anyone coming from over here, this side of the world, is going to hit the external Route 53, and it's going to go to our running asterisk instance in London. Like, so if I scaled that, I won't do it, but if I scaled that other one up, you'd see that you're running 2 asterisk. You can specify run one on the London node, one run on the SFO node. So you have, across the world, use the external DNS to bounce it over there. Again, you can throw in Camelio or Camelio in front of any of these things, make this even more complex. It's just a very basic way to get started. Anyone coming from South America, however, is much closer to NYC. That's terrific, right? Let's say asterisk needs to talk to Nginx. Well, let's say actually Nginx here is running as well, right? Because we're running some sort of proxy service. Nginx needs to talk to Postgres. Postgres is the database over here. Nginx talks to it. Nginx is running inside the overlay network, which is this white thing. Nginx can just say, hey, Postgres, give me this thing by saying Postgres, not having to refer to any kind of IP address. Postgres goes, dope, here you go, right back to you. Asterisk can't do that. It's not running on the overlay network. So to get to Postgres, it has to use, again, some sort of external DNS. It has to know where it is. But you can use the same kind of thing. Best part is, Postgres is running inside the mesh network. It's running inside the ingress. So any request to a Postgres through any of these nodes through the normal 5321, or whatever the port is, will get to this instance via the network. So asterisk just goes, oh great, just like contact any node in the company that's running to get to Postgres. It does that, and it just goes back and forth. So while asterisk is outside of that overlay network, the overlay network actually still provides, if you have other services running, which we almost always do, provides a layer of resiliency and access to those that asterisk can really leverage. And then asterisk itself, these are still containers, right? Still managed. So if this one dies off, it's just going to replicate it over to here. And you can run host mode containers on the same node as containers with the overlay network. They just don't see it. And I'm sure there's some tricky networking you can do to make them see it. I'm sure that's possible for people who are networking gurus. But again, we're trying to avoid doing these very complex single node processes where we have to define all this stuff, unless you really want to. I'm just going to breeze through these real fast because we're getting a little low on time. Again, there's built-in health checking in here. There's lots of fun options. I encourage you to go to the stack file and check it all out. You can do this kind of stuff. Like this is a good example. You can use SIPSAC. If you had inside of your container SIPSAC installed, you can do that to send an options ping to the Asterisk every little once in a while. You don't get that ping back again. It exits the container, it restarts itself. So we can kind of do a health check here. It says, interval is 30 seconds, the timeout's 15. Try it 3 times. Again, great health checking that just avoid having to write any cron scripts or anything else. It just does this. It's all built in. The Swarm just handles it all for you. Deploy it once and then just kind of wait for alerts to show up. Lots of other things to cover that we don't have time for. Data persistence, right? You can use, again, all of these things are running on random nodes anywhere. You don't have any control over where they get started unless you specify them. But again, try not to specify too much because then you're kind of destroying the point of the fact it can run anywhere and it's very resilient. So make sure you leverage things like AWS or Azure or Gluster to have this stuff copied around. Docker secrets is a fun thing. If you have, let's say, an SSL certificate that needs to be distributed across everywhere using Let's Encrypt, you can put that into the Docker Swarm as a secret. That will then be replicated across all the services that you allow it to. So you can use the same SSL cert in one place in the manager, and it just goes everywhere. And it actually sits. It's a read-only tempfs. It's mounted inside each container. You can also do that with config files. If you have special config files, just load them in there, and you can rotate those through. Again, label add, you saw that I was deploying back here. I do this constraint here where I do node label service as asterisk. So I put a label on the nodes I want to run asterisk on because I'm going to use that external DNS to do that sort of simple load balancing. And then the private registry here is a mistake showing me one of those. But private registry, again, if you want to download your own images from Docker, you log in on the manager node, doing just like Docker login. If you run them on Docker Hub, and then you can just refer to your own images and pull them down privately. So anyway, I think we've covered a lot of these final tips. Mostly that make your images as generic as possible. Remember these are cows and not kittens. Don't make them very precious. Keep them as generic as you possibly can. And can use API calls and external facilities to just pull everything in when the container is launched, if possible. Leverage all the pieces of Swarm that you can. They're actually all pretty well tested at this point, and they have a great set of regression scripts. So we can replace a bunch of auxiliary tools. And then again, think about this. Think about how, why you would want to do this, right? The reason I've seen recently, there have been a lot of installations put together by consultants that people don't understand how they all work, right? These are asterisks or free switch boxes that are sat there and they have all kinds of, they have 4 or 5 processes running. They have that SIPSAC going in the background, occasional cron scripts. All kinds of things are happening that no one knows what's going on. Someone came, deployed it a while ago, have no idea what's going on. If you had those containerized and in a service file, and a stack file that defines each service and what it does, it becomes much, much easier to maintain in the future because we're not all going to be in the same positions, or we're going to hire people or fire people. So you need to know what your network is doing. And this is a nice way of just defining it all in a very human readable format. And it also makes it, again, you can deploy this in production the same as in development. And for me, that's huge. Having development production parity is gigantic because if it runs locally, it should run in production exactly the same. The containers are immutable once created, assuming that all of your dependencies are correct, off it goes. Of course, you will still run into problems and you'll swear at it and be like, I thought Evan said, it was exactly the same, what a bastard. But, caveat emptor. So here you go. Again, I'm Evan McGee. You get a hold of me on Twitter or anywhere else. Any questions? Let me know.
Well, Evan, that was delivered with so much energy and enthusiasm, and there's so much information in there. Sadly, I don't think we've got any time for questions, but Evan will be around.